Hello again, this is Mr. Nelson here. I am going to talk about Objective 2 within Topic 1 of Module 2, and Module 2 is quadratic functions. And we're talking about their graphs and graph features of quadratic functions, and so Objective 1 was an intro to that. Now Objective 2 is going to be find graph features of quadratic functions, that's supposed to have an S, if given a picture of a graph. So hopefully by the end of this objective, if you were to be given a picture of a parabola, you could tell me 7 key pieces of information about it, all right? So by the end of this, you should be able to find the vertex, the domain, the range, the axis of symmetry, the x-intercepts and the y-intercepts, and then be able to tell me as well if it's positive or negative. So that is the goal of this objective, all right? I'm going to do 2 examples, and then I'm going to have you pause the video and try 2 on your own, and then after that, if you pause it and you got the right answers after you checked with my answers within this video, you can move on to the practice work. And again, it's 6 different graphs, and your goal is mastery 6 out of 6. So let's begin. If I was given a parabola, like in this problem number 4, I would notice a few key things right away. The first thing I would notice is that it opens down, all right? These endpoints go on forever, and it looks to be like a frowny face. And if you remember from the introduction video, there's the 2 options are, is this positive or is it negative? And I said that negative people make frowny faces, and so frowny faces open down. And so this parabola is negative because it opens down. And negative people are unhappy and they make frowny faces. All right, so just by looking at it, I can tell whether or not it opens up or down. Now let's move on to probably the most important piece of any parabola, the vertex. All right. If you remember from the video before, the vertex is either going to be a mountaintop or a valley, a maximum or a minimum. All right. And hopefully you remember from the video before as well. If it's negative, it'll always have a mountaintop. They go hand in hand. Negative parabolas have maximums. So this vertex is a maximum, all right? And it's right here. If you remember, the vertex is where the 2 sides of the parabola meet. And they are cut in half symmetrically at the x value of the vertex. So this vertex is, if you notice, it doesn't shift horizontally. This is the y-axis right here. This is the x-axis. It doesn't shift horizontally at all. It's sitting on the y-axis. And any x value on the y-axis is 0. And if there's no shift horizontally, I know that it didn't move, so the vertex is 0. But the y value of the vertex, let's count up. We can assume that it's a little hard to see, but we can assume that each one of these hash marks on this grid is just 1, all right? Unless otherwise noted, but hopefully you'd be able to see that if it was otherwise noted. So I'm going to count up 1, 2, 3, 4 spaces. So the y value of the vertex is 4. All right, I found my vertex of this graph. Now the vertex automatically tells me the axis of symmetry, because if you remember, the axis of symmetry is always the x value of the vertex, all right? And you need to write it like that, x equals 0, meaning that at the vertical line of x equals 0, it cuts it in half equally. Now let's move on. I'll save domain and range for last. Let's move on to the y-intercept. Now this isn't always the case, but this does happen. If you notice, the y-intercept, where it crosses the y-axis, is also the vertex in this case. And so the y-intercept always will have an x value of 0, which is true. We found that up here. And so that's the x value, and the y value is 4. So that is my y-intercept. All right, and again, just note that that doesn't always happen. The y-intercept won't always be the same as the vertex, but in this case it is. Now, the x-intercepts, where they cross the x-axis. And typically, there will be 2 different places where it will hit the x-axis if they are indeed x-intercepts. All right? At some points, if you look in this example over here, it only hits it once. Technically, there's still 2 solutions there, but we'll talk about that. So these x-intercepts, one right there and one right there, I need 2 different values. The first one is -2 comma 0, and the second one is 2, comma 0. Alright, and if you notice, the y-intercept, the x value, was 0, and in the x-intercept, the y value is 0. Alright, so far so good. Let's talk about the domain. I mentioned in the previous video that the domain of every parabola is negative infinity to positive infinity, or all real numbers. Alright, now the range is a little bit different. If you notice, if it opens down, please make note of that. If it opens down, which this one does, these endpoints go down forever. So the floor, the basement, is negative infinity. Alright? If it opens down, it'll always start with negative infinity. If it opens up, it'll always end with negative infinity. Alright? Keep that in mind. Now, this does have a ceiling. It stops at a certain point. It stops right here. And that is the vertex. And we said the vertex is 0, 4. The range is y values. From the previous video, the range is y values. This is the x value, this is the y value. I care about y values. So the ceiling of this function is the y value of the vertex. Alright, the vertex will always come into play for the range of a parabola. Alright, the ceiling of this is the y value of the vertex. And now at this point I'm done. I have found 7 key features of a parabola. Alright, let me move on to one more example, then I'll have you try 2 on your own. Alright, to begin, positive or negative in number 6. I look down and it's shifted a little bit, so it's moved a little bit, but it's still opening down, making a frowny face, so that means that it's negative. And I didn't make you understand this, but let's label this vertex over here. I didn't make you make note of this. This is a maximum, meaning if it's opening down, this will also be a maximum. You also need to know that. Alright? So technically, there's 8 things to find for each parabola. Now, it's negative, it's a maximum. Let's find the vertex now. Vertex has shifted left from the original one over here, or for the first one I did. Now this vertex is a plotted point of negative 2, 0. Alright? Negative 2, 0. Meaning that I also found my axis of symmetry. It's the x value of the vertex, x and y. So axis of symmetry is x equals negative 2. And let's try the y-intercept now. In this case, where it hits the y-axis, the vertical axis right here, is down right here, it looks like. And that's shifted down. Now the y-intercept, the x value is always 0. And the y value then is 1, 2, 3, 4. Negative 4. It went down 4. Alright, so y-intercept is 0, negative 4. Now if you notice, the x-intercept, again, this is a quadratic function, meaning that it's something x squared, meaning that it has 2 solutions. If you notice, it only hits in one point on the x-axis. And that in this case, the x-intercept is also the vertex. I'll do this in a different color just to show it a little bit. The x-intercept is also the vertex, negative 2, 0. But because this bounces, and we're going to talk about this more in Module 4, it bounces off that point. Technically, there is still 2 solutions, so this technically means that negative 2 has a multiplicity of 2, and you do need to write the multiplicity of 2. All that is saying is that negative 2 is the solution twice for this parabola. All right? It exists twice as the solution because it bounces off at that point. Over here, it didn't bounce anywhere. They went through both times, and there was 2 different ones. But here, it's the same one twice. So you do need to make note of that if it ever bounces off the x-axis. Now, finally, the domain. Domain is easy. It's all real numbers. And then the range, if you notice, it opens down. So it will always, if it opens down, it'll always start at negative infinity. But then it does have a ceiling. The ceiling exists right here. And if you remember from the first example, the ceiling, if it's the vertex is the maximum, then the ceiling will always be the y value of the vertex. And in this case, then, the y value is 0. So the range is negative infinity to 0. Now, at times, if you notice down here, example 5, you'll find that for the range, it opens up. So it'll end at positive infinity, but it starts down here at the vertex, the y value of the vertex. So in this case, the y value of the vertex is the beginning of the range because it opens up. All right, go ahead and pause the video and try these two on your own. You should have paused the video and tried these two on your own. A couple key pieces of information I want to note. This says x equals 7. That's a comma. X equals 7 for the axis of symmetry. So again, this one opens down, so it has a maximum. And the range begins at negative infinity and ends at the y value of the vertex, which is 7, 1. Notice that these hash marks are indeed changed a little bit. But the y value of the vertex is the ceiling of the range. All right? That's probably one of the hardest things to grasp in this concept. The x-intercepts exist as they do. Now at times you'll just see this be written as x equals 6 and 8. But I want you to get in the habit of knowing that at the x-intercept, the y value is 0. So I want you to write it as a plotted point too. Now in this case, the y-intercept you can't see. This would continue down forever. And then eventually, if this keeps going down, it would hit the y-axis right here at some point, but we just don't know what it is. And then indeed, it's opening down, so it's negative. Now over here, and it has a maximum here. Please make note of that. Over here, it's opening up, so it's positive, which means it has a minimum point, and that vertex minimum is right here, the x and y at 1 and negative 1. Domain is all real numbers. The range, again, if you notice, this is the big difference in the range, and this will give some people trouble. Please make note of this. All of our other ranges have been starting with negative infinity because they've been opening down, but now this one opens up, so the floor has become the vertex, whereas before the ceiling was the vertex. But we always start with the floor in the range, and now the vertex is our floor because it's opening up, so that begins with the y value of the vertex. So please make note of that. It's always floor to ceiling. Now this ceiling goes on forever, so it goes up to positive infinity. Axis of symmetry goes hand in hand with the vertex. The x-intercepts are right here, 0, 0, and 2, 0. And again, this could be x equals 0 and x equals 2. And then finally, in this case, the y-intercept is the same as one of the x-intercepts. Crosses the y-axis right there as well. So please check your work with mine. If there's any discrepancies or anything that you see different on your work compared to mine, please check with a neighbor. And if they can't tell your mistake, then please raise your hand and I will come check your work. And now you are free to move on. If you do understand these two, you're free to move on to the practice problems. And your goal is mastery 6 out of 6 by telling me 8 different things. Remember, max or min with these problems as well. So, hopefully at the end of this video, you know a little bit more about if you were given a graph of a parabola, can you tell me these 8 different things of the parabola? Goodbye.